Hey everyone, okay, back again, still reviewing. So we're gonna get into the next thing, which is talking about rational and irrational numbers. So if you guys remember, the definition of a rational number is you have to be able to write it as a ratio or a fraction. So like A over B, where A and B are integers. Okay? So remember, your integers, positive, negative, including 0. So those whole numbers, not, fraction over fraction kind of thing. So this first one's asking why is 0.333333 a rational number. This is something you guys could see on the test. And if you see it on the test, you can't just say, yes, it's a rational number. You have to explain why it is a rational number using that definition. Okay? So why is that a rational number? You would say, because 0.333 repeating can be written as 1 over 3, right, a third, and 1 and 3 are both integers, okay? So not just saying, yes, it is, explaining, yes, it is, and this is why it is. So then by the same token, when you're proving something's irrational, you're proving that you cannot write it as a ratio. So why is pi irrational? Because it cannot be written as A over B, where A and B are integers. Okay, this should be like a freebie question on the test if they ask you this question. So make sure those freebie questions are those ones that you feel really good about. You're being as descriptive as possible, so you're getting every single point that you guys can. All right, next part is talking about the different axioms. So when you're talking about the axioms, not only do you need to know is it associative, distributive, or commutative, you need to know if it's for multiplication or whether it's for addition. All right, so if you look on this first one, you have x plus 0 is still giving you x. Obviously, we're talking about the additive, okay, because that's addition, all right? And in this case, plus 0 is the additive identity. So, if you're adding 0 onto something, you're keeping the original thing that it was. So that's our additive identity. So if we kind of just skip around for a second and look around, if we look all the way to this last example, we're seeing the same kind of idea, but now this is talking about multiplication. Identity. So this one is our multiplicative identity. All right, so if you multiply a number by 1, you're getting your number back. All right, so those are our two identity. If we look at this one right here, the idea that you can add, or right here, multiply in either direction, that's talking about commutativity. All right, so for this first one, I'm just going to write, okay, so that's talking about additive, and it's the commutative property. This one right here, this is multiplication, and that's the commutative property. So commutative, you're thinking flip-flop, all right? So they can flip-flop with each other. Associative talks about parentheses. So if I take parentheses and I do this part first on this one and then multiplying the C on, versus multiplying B times C first and then multiplying the A on, this is associativity, all right? Either way, you're gonna get the same answer. This is obviously talking about multiplication, so we would say it's multiplication, and we would say that it is the associative. Again, on the test, make sure that we're writing whether it's additive or multiplicative, because you wanna get as many points as possible. And then the only one that combines addition and subtraction is this distributive one. So this is showing x, it gets distributed, you get xy and xz. All right, so those are those axioms. You just gotta know them, memorize them, get them down. If you see one on there, then awesome. Okay, next part is you need to be able to identify specific numbers belonging to specific sets, such as your integers, natural numbers, rational numbers, irrational numbers, and real numbers. Okay, the first one that is the easiest to see. When you think of real numbers, you're thinking of any number that's not I. So automatically, every single one of these, this is a real number. This is a real number. This is a real number. All of these are real numbers because real numbers are any number that you can think of except for I, your imaginary stuff. All right? Integers, remember integers are your negatives plus 0 and your positive, all whole numbers. So 2, this is an example of an integer. So remember, integers we're writing as that double bar Z. 5.7, that is not a counting number. That does not count. Negative 1/3, that does not count, but negative 10 does. So this is also an integer. Natural numbers are your counting numbers, only positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. All right, so our only natural number here is 2. And then rational, irrational, okay? It's one or the other. It doesn't get to be both, and every single one is one of them. 2, that is a rational number. We can write that as 2 over 1. Good. Pi, we talked about that earlier. Pi is irrational, so you denote that as the counter of the rational numbers. 5.7, we can write that as a ratio, so this is a rational number. Next one, negative 1/3, that's already written as a ratio, so obviously that is a rational number. Negative 10, we can write as 10 over 1. That's a rational number. And E is Euler's number. I talked about that in the last video a little bit. It's like 2.7, something like that. So that is an irrational number. Okay? So they're good with that. Next part, and this is the last thing I'm going to do in this video, is we are going to talk about, is it a function or not? Okay, so is it a function? On a graph, I'm thinking, does it pass the vertical line test? No matter where I draw that line on here, it's only hitting this parabola one time. This is a function. Okay, if I draw a vertical line through here, I'm hitting it 1, 2 times. This is not a function. I guess I can write F-U-N-C just so we know what we're talking about. Okay, so vertical line test when you guys are on a graph. When you guys are on a table, your Y values do not matter. So on this first one, doesn't matter that 4 is repeating over and over because we're not even looking at our Y values. We're only looking at our X values. 1, 2, 3. 1, 2, 3 does not repeat, so this one is a function. Again, Y values don't matter. Don't even look at them, all right? 2 and 2, X's repeat, so this is not a function, all right? All right, couple more. Anything that relates to any of the parent functions is going to always be a function, all right? So this is a linear function. It's gonna look something like that, right? Depending on what your scale is. This one would pass the vertical line test, obviously. So this one's a function. This is a transformation of your square root function. So again, this would look like -2, that's moving us right to, so it's gonna look something like that. This one is a function. And then when you guys are looking at mapping diagrams, you're looking, do any of your X values go to multiple Y values? So here, everything is only going to one thing. Doesn't matter that Y has multiple things going to it. All that matters is X is good all the way across. So this is a function, all right? Versus here, we're seeing multiple, 4 is going to 12 and 15. That means 4 is repeating, which makes this not a function. All right, hope that helped you out. We're gonna keep moving through slowly, so if you guys are ready, you guys can hop onto that next video. All right, see ya.